Hello, you beautiful people. Welcome back to GCSE Science Simplified. Last time, we saw how magnets push, pull, and point north. Today, we're taking the next step. What happens when electricity and magnetism team up? Because here's the surprising truth. Every time a current flows, magnetism appears. And that idea powers speakers, motors, MRI scanners, and even scrapyard cranes. Let's start simple. Take a straight wire. Nothing special. Now connect it to a battery so a current flows. Suddenly, that wire has a magnetic field around it. You can prove this with iron filings or plotting compasses. Place them around the wire, switch the current on, and they arrange themselves into circles around it. This shows something crucial. A current creates a magnetic effect, and the magnetic field forms concentric circles around the wire. The direction of that magnetic field depends on the direction of the current. Reverse the current, and the field reverses too. This is why in physics we use models, like the right-hand grip rule, to link current and field direction. The model doesn't create the field, it helps us predict what we can see. Now, not all magnetic fields are equally strong. Two key factors matter here. First, the size of the current. Increase the current and the magnetic field gets stronger. More moving charge means a bigger magnetic effect. Second, distance. The magnetic field is strongest closest to the wire and weaker as you move away. A straight wire is useful, but we can do better than that. Wind the wire into a coil, then connect it to a power supply. Now, each loop produces its own magnetic field. Inside the coil, those fields add together, forming a strong, almost uniform magnetic field, kind of like the one that we saw with a bar magnet. This coiled wire is called a solenoid. It's the simplest form of an electromagnet. Inside the solenoid, all the field lines point in the same direction. You remember the domains, those little arrows showing the magnets inside the material. These domains point the same direction, so they reinforce each other. Outside the solenoid, the field lines from neighbouring coils cancel out, making the field much weaker. This is why electromagnets are so effective. Strong where you need them, weak where you don't. Electromagnets are everywhere. Scrapyard cranes use them to lift cars. Switch the current on, the magnet works. Switch it off, the car drops. Doorbells, speakers, relays, and electric motors all rely on electromagnets. And unlike permanent magnets, electromagnets can be controlled. Stronger current means stronger magnet. So remember, a current creates a magnetic field. Stronger current means a stronger field, and a further distance away from it weakens it. Coil the wire into a solenoid and the fields add together inside to make a powerful electromagnet, one you can turn on and off wherever you like. This can be improved even further if you put a magnetic core in, like iron. And that's it. Electromagnetism. Another GCSE Science Simplified.